Good day, I'm Dr. Ting, and in this module 4.2, we are going to further discover deep learning, a subfield under machine learning. So deep learning is a branch of machine learning completely based on the artificial neural networks which mimic our human brain, how our human brains are working. In deep learning, we don't need to explicitly program everything, so we reduce the human intervention. Deep learning is a particular kind of machine learning that achieves great power and flexibility by learning to represent the world as a nested hierarchy of concepts, with each concept defined in relation to simpler concepts and more abstract representation computed in terms of less abstract ones. So let's further look at the deep learning. Okay, artificial network, neural network is the first model. The first model of artificial neural network is proposed in 1943. It is an analogy to the human brain, which greatly exaggerated. So this, you will be given a set of input and then calculate it and produce the output using a set of weights on the features and on the input. Then you will be going to see the different layers in the neural network, just like your human brain works layer by layer, filtering out. In a big picture, artificial intelligence, a technique which enables machine to mimic the human behavior, and a part of artificial intelligence is called machine learning, subset of the AI technique, which use statistical methods to enable machine to improve with experience. Then under machine learning, we have a subfield called deep learning, subset of machine learning which makes a computation of multi-layer neural network visible. Let's try to compare machine learning and deep learning. So deep learning works on large amount of data sets, and machine learning works on small amount of data set for accuracy. Then machine learning depend on low-end machine, but deep learning we depend on high-end machine. Machine learning divides the tasks into subtasks, solve them individually, and finally combine the result. Deep learning solves the problem end to end. You don't have to break it down. Machine learning will take less time to train, but deep learning, you need a longer time to go through the data set because of a big data set, and also the analysis part will take longer time. Machine learning testing time may increase, but deep learning less time to test the data. Looking at the diagram again, machine learning and deep learning, with deep learning with more layers in the neural network. Machine learning might require human in machine learning algorithm intervention, especially for supervised learning. We will need to label the data set. We will need to label the features, which one is input, which one is the output, which one is predicted outcome. For deep learning, we need lower need for human intervention, and the machine will learn from the environments, from the sample that you provide to them. Different types of deep learning, deep neural network, a neural network with a certain level of complexity, with multiple hidden layers in between input and output layers. And a deep belief network, a class of deep neural network, multi-layer belief networks. Recurrent network allow for parallel sequential computation, similar to your human brain. Large feedback network of connected neurons. Neurons are the connected sensor or stimulator in your human brain. So we're trying to mimic these neurons. Able to remember important things about the input they receive, and hence enables them to be more precise. Now let's discover the steps in the deep learning. First, you definitely have to understand what kind of problem or what goal that you would like to achieve, and check whether deep learning can achieve or solve your problem. Then number two, you will have step two, you will have to identify relevant data and prepare the data, pre-process it, then input into the tool, the machine learning tool, then choose the algorithm that you want to use, then train your algorithm. So we'll have the training data set, we'll have the test data set, validation data set, then test the model's performance. These are the example of languages and tools for deep learning. The popular one will be R, Python, MATLAB, Java, And then the tools, you can use Anaconda, Jupyter, Notebook. Let's take a look at some real-life examples of deep learning, what we actually apply, how we apply it in which field. Task give another real-life example of deep learning, how to recognize square from other shapes. Check, for example, you can check the four lines, is it close, and then other shape perpendicular from each other, that's all the sides are equal. So this is how you can actually identify the shapes, a very simple image. And recognizing an animal is a cat or a dog, you have to define the feature, the facial features, which are important for classification, whether it is classified into the dog or into the cat category. System will then identify this automatically. Machine learning will manually give out those features for classification. For dog, what are the features? For cats, what are the features? Deep learning is complex. It's a complex task of identifying the shapes and broken down into simpler tasks at a larger size. If you have a large image with several objects, then it will break down into several tasks. What are the advantages, disadvantages, and limitations of deep learning? Advantages: best in-class performance on problems, reduce the needs for feature engineering, reduce the involvement of human, eliminate unnecessary costs, and identify defects easily. They are difficult to detect. Disadvantages is that you will need to collect large amount of data for training in order to achieve the high accuracy, high performance. And then computationally expensive to train because of big data, so you need a powerful machine to run. No strong theoretical foundation, so we need a lot of research. Limitation is that learning through observations only. So we might have some issues of biases, especially if you provide the image with biased image. Like for example, you provide a lot of cartoonists of cats images, which might not fit into what is the real life of a cat looks like. So if the issue of biases occur here. Some applications of deep learning: automated text generation. You give it the text, and then you are going to identify word by word or character by character, learning how to spell, punctuation, how to form the sentence, or even capture the style of writing. In healthcare, helps in diagnosing various diseases and treating it by looking at perhaps the cancerous cells with the image from the X-ray, then they'll be able to identify. But again, you will need a pool of data or a large big data set or images to train the algorithm. Automatic machine translation: certain words, sentences, or phrases in one language is transformed into another language. So this is this will need the text recognition, image recognition in order to extract the form. Say for example, you can there are many applications nowadays that you can capture the picture, the image, with the works. Like for example, you capture an image of the Korean works on that image because you want to find out what is that product, and the application will be able to quickly translate the words, identify or recognize the words on an image. It's not a text. Yeah, translating text from Korean works into the English might be much easier, but in this case, the texts are actually embedded inside an image. So how do you extract the text and translate it? Image recognition: recognize and identify people's objects in the image, and as well as to understand content and context. Where is this image? How many people are there? Or how many animals inside there? So this is used in gaming, retail shop, tourism. Predicting the earthquakes: teach a computer to perform viscoelastic computations which are used in predicting the earthquakes. So you have to give it a big set of data in order to do the prediction. Let's take a look at one of the very popular application of deep learning: image classification. Deep learning involves the use of computer system known as neural network. And a neural network, we have the input filters through hidden layers of nodes. We have many nodes, and each nodes are connected together. So one layer of nodes, we call it as layer. Each node processes the input and communicate their result to the next layer of nodes. So we have one layer of nodes, one layer of nodes. The first layer is going to integrate with another layer. It is repeated until it reaches an output layer and the machine provides its answer. That's why we have many layer, multi-layer. Different types of neural network based on how the hidden layers works and how many layers they have. Image classification with deep learning mostly involve convolutional neural network, CNN. The nodes in the hidden layers don't always share their output with every node in the next layer, known as convolutional layers. So we will look at this, how this CNN works. Now, what is this CNN? Deep learning allows machine to identify and extract features from the image. They learn from the features, like for example, how's the shape of your eyebrow and the eyes. So they are actually extracting all these features from the images. So the programmer don't need to enter these filters by hand. They are learning from the experience. The machine are learning from the images or from the experiences. Now let's take a look at convolutional neural network. The CNN is a class of deep learning neural networks, represent a huge breakthrough in the image recognition, most commonly used to analyze the visual imagery. You give it an image, then it will tell you what is this image. The layers in CNN, including these 4 layers, convolutional layers, ReLU layers, pooling and fully connected layers. So these are the architecture. This is the architecture, how it looks like. The 3 main layers are the convolutional layer, pooling, and fully connected layer. Let's take a look at this quick video clip to explain on CNN further.
Okay, pop quiz. What am I drawing? I'm going to make 3 predictions here. Firstly, you think I drew a house, you'd be right. Secondly, that it just came really easily to you, it was effortless. And thirdly, you're thinking that I'm not much of an artist. And you'd be right on all counts there. But how can we look at this set of geometric shapes and think, oh, house. If you live in a house, I bet it looks nothing like this. Well, that ability to perform object identification that comes so easily to us does not come so easily to a computer, but that is where we can apply something called convolutional neural networks to the problem. Now, a convolutional neural network, or a CNN, is an area of deep learning that specializes in pattern recognition. My name is Martin Keane, and I work in the IBM garage at IBM. Now, let's take a look at how CNN works at a high level. Well, let's break it down. CNN, convolutional neural network. Well, let's start with the artificial neural network part. This is a standard network that consists of multiple layers that are interconnected, and each layer receives some input, transforms that input to something else, and passes it as output to the next layer. That's how neural networks work. And CNN is a particular part of the neural network, or a section of layers. Let's say it's these 3 layers here. And within these layers, we have something called filters. And it's the filters that perform the pattern recognition that CNN is so good at. So let's apply this to our house example. Now, if this house were an actual image, it would be a series of pixels, just like any image. And if we zoom in on a particular part of this house, let's say we zoom in around here, then we would get, well, the window. And what we're saying here is that a window consists of some perfectly straight lines. Almost perfectly straight lines. But you know, a window doesn't need to look like that. A window could equally look like this, and we would still say it was a window. The cool thing about CNN is that using filters, CNN could also say that these two objects represent the same thing. The way they do that then is through the application of these filters. So let's take a look at how that works. Now, a filter is basically just a 3x3 block. And within that block, we can specify a pattern to look for. So we could say, let's look for a pattern like this, a right angle in our image. So what we do is we take this filter, and it's a 3x3 block here. We will analyze the equivalent 3x3 block up here as well. So we'll look at, first of all, these first group of 3x3 pixels, and we will see how close are they to the filter shape. And we'll give that a numeric score. Then we will move across one corner to the right and look at the next 3x3 block of pixels and score how close they are to the filter shape. And we will continue to slide over or convol over all of these pixel layers until we have mapped every 3x3 block. Now that's just for one filter, but what that will give us is an array of numbers that say how closely an image matches our filter. But we can add more filters. So we could add another 3x3 filter here, and perhaps this one looks for a shape like this. And we could add a third filter here, and perhaps this looks for a different kind of right angle shape. If we take the numeric arrays from all of these filters and combine them together in a process called pooling, then we have a much better understanding of what is contained within this series of pixels. Now that's just the first layer of the CNN. And as we go deeper into the neural network, the filters become more abstract, or they can do more. So the second layer of filters perhaps can perform tasks like basic object recognition. So we can have filters here that might be able to recognize the presence of a window, or the presence of a door, or the presence of a roof. And as we go deeper into the CNN to the next layer, well, maybe these filters can perform even more abstract tasks, like being able to determine whether we're looking at a house, or we're looking at an apartment, or whether we're looking at a skyscraper. So you can see the application of these filters increases as we go through the network and can perform more and more tasks. And that's a very high-level basic overview of what CNN is. It has a ton of business applications. Think of OCR, for example, for understanding handwritten documents. Think of visual recognition and facial detection and visual search. Think of medical imagery and looking at that and determining what is being shown in an imaging scan. And even think of the fact that we can apply a CNN to perform object identification for badly drawn houses. If you have any questions, please drop us a line below. And if you want to see more videos like this in the future, please like and subscribe. Thanks for watching.
So eventually, when you give an image to a computer and ask a computer or ask a machine learning or the deep learning to identify this image, it will represent it into the one that you see here on your right-hand side. So that's called image classification. They are going to classify going through the filters, through all the layers, and eventually represent it the most match or classified image based on the filter that they have. So the more filters that you provide, or the more experience that you provide to the deep learning, then the more accurate it will become. So this is how it works. The convolutional layer, which will be mapping the image going from 3x3 block, and in order to produce the kernel here. And eventually they are going to represent the image, the kernel, the features map, and tell you that this is classified under a cat category. So let's take a look at now the deep learning applications. Instant visual translation, you can use it to predict the future as well. The chatbots, medical care, self-driving car, colorizing the image, read lips movement, photo description, deep dreaming, advertising. If you're interested to find out more, there are many research that have been done in all of these applications, and some of it are actually in the real world. It's already in the real world application. Some challenges in the deep learning, bias in the algorithm, they can contain unintentional bias. It all depends on the data that you provide to the machine. Even if the bias is removed, there can be unintentional bias in the data set that you provide to the machine unintentionally by the human. We don't know. Susceptibility to adversarial attacks again, and there is actually an issue of privacy as well when you collect big data as well. Limited ability to generalize it because it will be very focusing, very specific use case of, like for example, if you're focusing in cat only, then that machine algorithm will be able to only know cats only. Lack of explainability, very difficult to explain actually. Correlation, but not cause. Okay, causality means what is the cause of this? If you have this image produced now in the accident, you recognize all the images, available images, but what is the cause of it? We don't know. So there is no causality, cause and outcome. You can only detect what is inside the image. With that, that's all for this module, and I will see you again in the next video clip.